Welcome to this explainer. Today, we're diving into an absolute masterclass to uncover the actual source code of the universe. We're going to scale all the way from the everyday objects you can literally reach out and touch, right down to the absolute mind-bending extremes of reality. We're talking matter, energy, space, time, the whole shebang. Here's our roadmap for the journey. We'll start with the scientific method, move into everyday reality, explore the invisible web, and then totally break reality with quantum mechanics. After that, we'll accelerate to the ultimate speed and finally take a look deep inside the atom's core. Let's get into it.
Section 1. The scientific method, or how we actually know what we know. Because before we can even start to explore the specific rules of the universe, we kind of need to understand the rigorous framework that lets us discover them in the first place, right?
You see, physics isn't just some boring, static collection of facts. It's a living, evolving process. It all kicks off with observation, carefully measuring natural phenomena. Then that sparks a hypothesis, which gets relentlessly tested through experiments until it finally hardens into a mature, well-tested framework that we call a theory. Honestly, this cycle right here, it's the absolute engine of all scientific discovery.
Moving on to Section 2, the rules of everyday reality. Classical mechanics and thermodynamics. Now we're looking at the predictable clockwork universe at the human scale, built right on the bedrock originally laid down by Galileo and Newton.
This essentially defines the physics of the stuff you interact with every single day. Classical mechanics governs exactly how mass, force, and energy interact. It gives us this incredibly reliable mathematical framework to predict pretty much everything, from the exact arc of a baseball you throw in the backyard, all the way up to the orbit of a massive planet around the sun.
So the absolutely crucial takeaway here is that all everyday movement is strictly bound by Newton's three laws of motion. Whether it's the inertia that keeps an object totally at rest for that first law, the precise calculation of force using F equals ma for the second, or the undeniable reality that every single action has an equal and opposite reaction for the third, well, these three rules form the absolute bedrock of our macroscopic reality, no exceptions.
Now, when objects actually interact in this classical world, things get interesting. The results can vary wildly. In inelastic collisions, think of two billiard balls perfectly snapping off one another. Mechanical energy is completely maintained within that system. But in inelastic ones, like a really messy car crash, kinetic energy seemingly leaks out into the surrounding environment as heat, sound, or physical deformation.
And speaking of that leaking heat, the second law of thermodynamics has a massive, massive real-world implication because the entropy, or basically the disorder, of a system never decreases. Some energy is literally always wasted as heat. This inherently guarantees that perpetual motion machines are completely 100% impossible. The universe basically demands a permanent tax on all energy transfers.
Which brings us to Section 3, the invisible web, waves and electromagnetism. Now that we've got everyday physical objects sorted out, let's take a look at the hidden, invisible phenomena completely surrounding us.
A staggering amount of energy travels through our world via waves. Whether it's the actual sound of my voice hitting your ears right now, seismic vibrations rolling deep through the earth, or just massive ocean swells, they all inherently share these specific physical properties. They manage to transfer energy from point A to point B without permanently moving the actual matter along with it. Pretty cool, right?
And this leads us to a monumental historical breakthrough. Maxwell's equations prove that electricity and magnetism aren't just kind of related, they actually generate each other in a continuous wave. And the speed of that wave? It matched the speed of light perfectly. That proved once and for all that the light we see with our very own eyes is quite literally just an electromagnetic wave.
Okay, so we've mastered the rules of the everyday predictable universe. But I want you to really ask yourself, what happens when we pull the rug out? What happens when we zoom way, way down into the extremely small subatomic level where these rigid classical laws suddenly just stop working altogether?
Welcome to Section 4, Breaking Reality, Quantum Mechanics. This is an incredibly precise but radically counterintuitive branch of physics that pretty much shatters everything we just learned about the everyday world. The contrast here is genuinely jaw-dropping. While a planet's orbit in classical physics is mathematically certain, down in the quantum realm, nature operates on pure probability and wave-particle duality. We can really only guess the likelihood of where a subatomic particle might be. It demands a total, fundamental revision of our deepest intuitions about how stuff works.
Because we can never simultaneously know both the exact position and the momentum of a particle, reality itself becomes fundamentally fuzzy at the lowest levels. And listen, this isn't some glitch in our microscopes. It is an intrinsic feature of reality. It's what allows for completely impossible behaviors, like particles quantum tunneling straight through solid, otherwise impenetrable barriers. There's simply no way around it.
But wait, that fuzziness scales up. Let's look at Section 5, the ultimate speed, special relativity. If the subatomic scale breaks our intuition of space and certainty, moving at extreme velocities utterly shatters our intuition of time itself. Check out this staggering number, almost 300 million meters per second. That is the speed of light in a vacuum. And Einstein's absolute genius was realizing that this speed is absolute. It is exactly the same for every single observer, regardless of how fast you or the light source are moving. It is the literal, ultimate cosmic speed limit.
So the crucial takeaway here is this. If the speed of light cannot ever change, something else has to give. That something is space and time themselves. The faster you travel, time literally ticks slower for you compared to a stationary observer, and your physical length actually shrinks in the direction of motion. I mean, at everyday speeds, these effects are invisible, but as you approach the speed of light, they become a mind-bending, undeniable reality.
And of course, Einstein's famous E=mc² equation proves that mass and energy are fundamentally the exact same thing, just two sides of the same coin. The c² in that formula is a massive multiplier. That means a tiny bit of matter contains a staggering amount of locked-up energy. This is the exact reason why stars shine and how nuclear power works, which actually bridges us perfectly into our final act.
Section 6. Inside the atom's core, nuclear and particle physics. Let's dive all the way down to the ultimate foundation of existence, the fundamental forces governing the particles there, and the energetic reactions that light up the cosmos.
It's wild to think about, but everything that happens in the universe, everywhere, is driven by just these four fundamental forces. And the relative strength here is just shocking. Gravity, the immense force holding our entire galaxy together, it's incomprehensibly weak. We're talking a fraction with 38 zeros compared to the strong nuclear force binding a microscopic atom.
These four forces act upon foundational building blocks to complete what physicists call the Standard Model. This incredible mathematical framework, from the quarks making up protons, to the electrons orbiting them, to the force-carrying bosons, well, it was triumphantly verified when we officially discovered the mass-giving Higgs boson at CERN back in 2012. It's like a giant puzzle finally coming together.
To wrap up this explainer, we really have to look at the big picture. We've explored the unbreakable laws of mechanics, the utter weirdness of quantum probability, and the fundamental particles of matter. But remember the second law of thermodynamics? The overall entropy, or disorder, of the universe is constantly increasing. This is the arrow of time itself. So I'm going to leave you with this provocative thought to ponder. If our physical reality is permanently locked on a one-way trip toward maximum disorder, what exactly does the ultimate fate of the universe look like? What happens when the cosmic clock finally winds down?